going to look at solving our trigonometric equations, and you'll find that we solve these the same as we solved our algebraic equations, such as taking the equation that we have here, 5x minus 3 equals 3x plus 9. Well, one of the things that we wanted to do was to get our variable terms on the same side. And we know that we have the addition property of equality that says if we add or subtract the same number to both sides of the equation, then it retains its equality. So we would have 2x minus 3 equals 9. Then we can add 3 to both sides to get our variable term alone. And we have 2x equals 12. Then to solve for our x, we're wanting a coefficient of 1, so we can either divide both sides by 2, or we can multiply both sides by the reciprocal by 1/2. And we get that x equals 6. Then we can check our answer by substituting back in. 5 times 6 is 30, minus 3 is 27, 3 times 6 is 18, plus 9 is 27. So as long as we add or subtract the same thing to both sides of the equation, and we either multiply or divide both sides of the equation by the same number, then we can solve it. So let's look at a trigonometric expression, and we're going to use these same methods in solving. If we have the expression 2 cosine theta minus 1 equals 0. And in these, we're going to be finding all the values for theta between 0 and 360. Now we'll look at some later where we find all of our answers, and then we'll also look at some where we deal with radians. But we're going to find all the values for theta between 0 and 360 that will make this equation true. So we treat the cosine theta as our variable. We'd do this problem the same as we would do 2x minus 1 equals 0. So we want to get our variable term alone, so we're going to add 1 to both sides. So we have 2 cosine theta equals 1. Then we want to divide both sides by 2, or you could multiply by 1/2. Most of you probably divide by 2. So the cosine of theta equals 1/2. Now we want to find our angle. And the first few we're going to look at, these are going to be angles you know. We're looking for what angle has a cosine of 1/2. Well, we know that that's 60 degrees would be our reference angle. But we want to give all the values between 0 and 360. So first of all, we figure up our reference angle. It's going to be 60. Now, this was positive, so we think, well, the cosine's positive in the first quadrant and in the fourth quadrant. So 60 is our reference angle, which in the first quadrant, that means our angle is 60 degrees. And then in the fourth quadrant, it would be 360 minus the 60 degrees, or 300 degrees. And so we found all of our values for theta between 0 and 360 that would make that true. Okay, let's look at another one. 2 tangent theta plus 2 equals 0. Well, we want to solve for tangent theta, so we'll subtract 2 from both sides. So we have 2 tangent theta equals -2. Then we want to get our variable term, so we'll divide both sides by 2, and we get that the tangent of theta is -1. Now we know that 45 degrees has a tangent of 1. So what we think of is 45 degrees will be our reference angle. Now since our function is negative, that means that we're either in quadrant 2, because the tangent's negative in quadrant 2, or quadrant 3. So if our angle's in quadrant 2, it would be 180 minus 45, which would be 135, would be our angle of rotation. If we're in quadrant 4, it's 360 minus 45, or 315 degrees. And remember, we're giving these between 0 and 360, so you would always give them as positive angles. Let's look at this one. And in this one, we're going to give our answer in radians. Okay, here we have a problem. Here we have a problem that we want to do. And in this problem, we're going to let t be between 0, not 0 degrees, just between 0 and 2 pi. So this just means that this is our way of saying that we want our answers done in radians. Now, we solve this just like we would solve the square root of 3 plus 5x equals 3x. We want to get our variable terms on the same side. So we'll subtract 5 sine t from both sides. And we get the square root of 3 equals negative 2 sine t. Then dividing both sides by negative 2, we get negative square root of 3 over 2 equals the sine of t. Now, we want to figure up then what angle has a sine of negative square root of 3 over 2. And when we've done this before, we've actually written this as the inverse sine of square root of 3 over 2 equals t. That's our way of writing this, but most of the time we can just say, what angle has a sine of square root of 3 over 2? Well, we know that that's 60 degrees, which is pi over 3 in radians. Now, what we need to do, we figure up our reference angle first, then we figure up our quadrants. So we know that the sine of 60, or pi over 3, is the square root of 3 over 2, but this is negative, so that means that we're in quadrant 3 or in quadrant 4. Sine is positive in quadrants 1 and 2. It's negative in 3 and 4. Now, here's where we do our addition. We know from 0 all the way around to pi, here is pi, which, since we need it to be thirds, would be 3 pi over 3, plus pi over 3 would be 4 pi over 3. In the fourth quadrant, this would be 2 pi, which, if we want 2 in thirds, would be 6 thirds. So 6 pi over 3 minus pi over 3 would be 5 pi over 3. So it's not hard to give our answer in radians. Okay, let's look at this problem. Three sine t plus 5 equals negative 2 sine t. And again, we're going to give our answer in radians. So let's get our sine t's on the same side. So we're going to subtract 3 sine t, which gives us negative 5 sine t. Dividing both sides by negative 5, we get negative 1 equals the sine of t. So what we're looking for is what angle has a sine of negative 1. Well, we know that the sine is 1 on the y-axis. At pi over 2, or 90 degrees, it's positive 1, and at 3 pi over 2, it's negative 1. And since that's the only choice we have, it's going to be at 3 pi over 2, or our 270. We know that we've got 0, and then at 90, which is pi over 2 in radians, and since we want our answer in radians, it's okay to think at 90, but then we need it in radians. And then at 270, we have the negative value. Well, that would be 3 pi over 2, halfway between 1 and 2, 1.5. And so we're able to solve. Okay, in all of those problems, we had exact values. We knew what our angles were. But there are times that we may not know, and so we'll have to use our calculator. So let's look at a problem like that. Let's say that we have 4 sine theta plus 3 equals 0. So we're going to subtract 3. So we get 4 sine theta equals negative 3. So the sine of theta equals negative 3/4. Now I always check to see if this is an angle that I know, but it's not. I don't know what angle has a sine of 3/4. So we're going to use our calculator, and what we're going to look for is the inverse sine of negative 3/4 equals theta. But we're going to want theta between 0 degrees and 360. So let's go to our calculator. And we need to make sure, since we're doing this in degrees, that our calculator is in the degree mode, and mine is. And then we'll just simply say second sine. That gets our inverse sine or our arc sine. And if we put in negative 3/4, now we know that's 75/100, but you can just put in 3 divided by 4 so that it looks like what you've got there. Enter. Now, remember the way that your calculator gives back your answers is based upon inverse functions. And so for the sine, it gives it back to us in the fourth quadrant as a negative angle. It gives it negative 48.6 if we do this to the nearest tenth. Gives it in the fourth quadrant as negative 48.6 because it was negative. Now we know that because it's negative, we're going to have an answer in the third quadrant and the fourth quadrant. Well, remember that 48.6 is your reference angle. So what we want, and because it's already negative in our calculator, it's easiest to go ahead and get this one. We want the angle that rotates in a positive direction. Well, that would be all the way would be 360 minus the 48.6 would be our angle. So by using our calculator, since it's already there as a negative angle, we can just say plus 360. Negative 48.6 plus 360 is the same as 360 minus 48.6. So that would be 311.4. So theta could be 311.4. Then if we need it in the third quadrant, well, that would be 180 plus 48.6. So we would just put in 180 plus 48.6. So that's 228.6. So in some ways it's a little bit harder with using the calculator because of the way the calculator returns the answers. But it's also a way of checking. Okay, let's look at another one. 4 cosine theta minus 1 equals 3 cosine theta plus 4. Well, we need to get our cosines on the same side, so I'm going to subtract 3 cosine theta. And we get cosine theta minus 1 equals 3. Adding 1, cosine theta equals 4. Whoops, that's a 4, and 4 plus 3 is 5. This should be a 4. I didn't look at my problem good. And then adding 1, I get 5. Now, one of the things we talked about is that our cosine is always between -1 and +1. The cosine never has a value greater than 1. So we know that this can't be true. So just recognizing that there's no angle that's going to have a cosine of 5, we can go ahead and say there's no solution. But if we forgot, which is easy to do, then we could go to our calculator and we could put in second cosine, inverse cosine of 5, and it's going to give us a domain error, which means then uh, there's not a possibility for that answer. Now, all of these were what we would call linear type equations, and it was just one variable. We were able to solve for that just like we would in algebra. But we can also have other types of equations. We can have quadratic equations. We can have equations with more than one variable that we will have to do some changing for. So we want to look at a few of those. And we're going to have a few that are already factored for us, but there's some that we'll have to factor. We'll do more factoring in another lesson. But if we have the cosine x minus 1 times 2 cosine x minus 1 equals 0. Now, when we were solving our quadratics back in algebra, we learned that if we could write them in factored form as a multiplication problem, then we knew that one of those factors had to be 0. The only way you get 0 for an answer is if you're multiplying by 0. So we know that one of these factors has to be 0. We're going to look for all of our answers between 0 and 360. So what we do is we set each factor equal to 0. So cosine x minus 1 equals 0, and 2 cosine x minus 1 equals 0. And we'll simply solve. So we'll add 1. So the cosine of x equals 1. Now we know that the cosine of 0 equals 1. And you might say, well, also at 360, but notice when we put in our domain, we said we would include 0, but we wouldn't include 360 because it's simply 0 again. So x could be 0 degrees. Here we would solve, so we'll add 1, divide by 2, and we're looking for an angle whose cosine is 1/2. Well, we know that's 60 if we're in the first quadrant. But the cosine is positive in the first quadrant. It's also positive in the fourth quadrant. So 60 is our reference angle. So in the first quadrant, it's 60. In the fourth quadrant, it's going to be 360 minus 60, which is 300. And remember, we always give angles between 0 and 360. We're not going to give negative angles as our answer. All right, let's look at another one. Sine x plus 2 sine x cosine x equals 0. And for this one, let's give our answer between 0 and 2 pi. So we're going to give our answer here in radians. Well, now this one has two different variables. It's got a sine and it also has a cosine. One of the things we always check is, can we factor it? We can't solve it as long as we have a plus or minus. It has to be written as a multiplication problem so that we can set each factor equal to 0. So if you notice, we have a common factor of sine x. So we'll factor out a sine x. Sine x times 1 is sine x. Sine x times 2 cosine x would be 2 sine x cosine x. Now we set each factor equal to 0. So sine x equals 0, or 1 plus 2 cosine x equals 0. So here we're looking for an angle whose sine is 0. Well, back in an earlier lesson, we learned that the sine of 0 was 0, and also when we reflected it across the x-axis, so at pi, 180 degrees, or at pi. So x equals 0, or x equals pi. Here we'll subtract 1, divide by 2, so the cosine of x equals negative 1/2. Now, since my cosine is negative, I know that I'm either in the second quadrant or in the third quadrant. What I need to do is to get my reference angle. Well, the cosine of 60 degrees is 1/2, and 60 degrees in radians is pi over 3. So to get my angle of rotation, this would be 1 pi, which would be 3/3 pi. So it would be 3/3 minus 1/3 would be 2/3, or 3/3 plus 1/3 is 4/3. And those are the values of x. So we ended up with 4 different answers. Now, in all of these, we've been asked to find our answers between 0 and 360, where we just did one rotation. But we might need to find all of our answers forever. And so we know that those would simply be coterminal angles that we get by adding or subtracting 360. So let's look at how we would go about writing our answers for that. Let's take the problem 2 sine theta minus the square root of 3 times 2 sine theta, 2 sine theta, minus 1 equals 0. And we're going to give our answers in degrees, but we're going to give all of the answers. And just to see how we would go about writing these when we want all of the answers. And then we'll look at one where we give all of the answers in radians. So we've got it in factored form, and we can set each factor equal to 0. So 2 sine theta minus the square root of 3 equals 0. And 2 sine theta minus 1 equals 0. Adding the square root of 3 and dividing by 2. Okay, so we're wanting to know what angle has a sine of square root of 3 over 2. We know that's 60. Now, which in radians is pi over 3. Okay, we have to think about the positive and the negative. Sine is positive in the first, and it's positive in the second. So pi over 3 is our reference angle. So one angle that the sine could be, that theta could be, would be pi over 3. Now, it's also going to be all the angles that are coterminal to that. So the way that we write that, a rotation is 2 pi. So we would write this as plus 2 pi times n, where n is an integer. So if n is 1, well, if n is 0, then it's pi over 3 plus 0, which is pi over 3. If n is 1, Well, it's pi over 3 plus 2 pi, and so that would be 7 pi over 3. If n's 2, then we went around. Went around once, we went around twice, and then we went pi over 3 more. We could even have it as a negative integer, which would give us our angle rotating in a negative way. Okay, that's if it's in quadrant 1. In quadrant 2, that would be 3/3 minus 1/3, so it would be 2 pi over 3. And then plus 2 pi n. So to give all the values forever, all you have to do is to take your answer and then add 2 pi n. Now we will add 1, divide by 2. Okay, we want all the angles whose sine is 1/2. Well, we know that our reference angle would be 30, which is pi over 6. Again, we're positive, so that would be in the first quadrant and the second quadrant. So that means that theta could be pi over 6 plus 2 pi n, or theta could be, in the second quadrant, that would be 6/6 minus 1/6 would be 5 pi over 6 plus 2 pi n. And that gives us all the possibilities. If we were doing it in degrees, we would simply add 360 in, and that would get all of our possibilities that way. Now, so far most of the problems I've shown you were already in factored form. We did have one problem where we factored out a sine theta. It was in both terms. But we could have a problem in the form of 2 cosine squared theta plus 11 cosine theta equals -5. Well, this is in the form of a quadratic. And we're going to solve it just like we would a quadratic. This is in the form of 2x squared plus 11x equals -5. And we know to solve this, we would add 5 to both sides. Okay, now we need to factor this quadratic. And sometimes it may be easier for you if you keep it in just terms of x's and go through and think of factoring, how you would factor this and then transfer your answer. But we're going to deal with it in terms of cosine. So we have a quadratic. We have 3 terms. My coefficient's not 1. So some of you may have learned to factor this by using a trial and error. I learned to factor it by what's called the AC method. So we're going to multiply the coefficient for the squared term times the constant. 2 times 5 is 10. So we have 10 cosine squared theta. We want numbers that multiply to be 10 and add to be 11. Well, that's 1 and 10. So our numbers then are going to be 1 cosine theta and 10 cosine theta. The signs are the same. That's why we added them to get 11. And this tells us that they were both pluses. And there's some lessons on factoring from algebra that you may need to go back and review. Now we're going to factor by grouping. In this first group, we have a common factor of cosine theta. Cosine theta times 2 cosine theta would be 2 cosine squared, plus cosine theta times 1 would be cosine theta, plus common factor for these two terms is 5. This is called factoring by grouping. 5 times 2 cosine theta would be 10 cosine theta. 5 times 1 is 5. Now we have the common factor of 2 cosine theta plus 1 times cosine theta plus 5. equals 0. So we'll set each factor equal to 0. We have 2 cosine theta. We're going to give our answers here in degrees, but we're going to give all of our answers. 2 cosine theta plus 1 equals 0. I'm not sure why that kept cutting out, but we've got it written 2 cosine theta plus 1 equals 0. We would subtract 1. And then divide by 2. So the cosine theta equals negative 1/2. Here cosine theta equals negative 5. So we're looking for an angle whose cosine is 1/2. Well, we know that's 60 degrees, and we're wanting this in degrees. But since it's negative, we're in the second or the third quadrant. Reference angle 60. So in the second quadrant, that's 180 minus 60, which is 120. And then we want all the answers, so plus 360n. In the third quadrant, it's 180 plus 60, which is 240, plus 360n. And that gets all of our answers. Here, there is no angle whose cosine is going to be negative 5. Remember, our answers are always between negative 1 and positive 1. So that gets us all of our answers. So you may have to do some factoring, just like you would with your polynomials. It's also possible that you will need to use the quadratic formula. Now, to use the quadratic formula, we want to have it in descending order in the form of a quadratic, ax squared plus bx plus c. And the first few times I saw it this way, it intimidated me, and so I went over and I said, well, this is 2x squared plus 2x minus 1 equals 0. And I solved, well, it saw that it was exactly like what I did in algebra, and so it wasn't nearly as intimidating. But we might want to check 2 times 1 is 2. There are no factors of 2 that subtract to be 2. So we can't factor this. So we have to use the quadratic formula. So that tells us then that the cosine of theta is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we use our quadratic formula just like we would have used with the x's. We just use our coefficients, the a, b, and c. So this is negative 2 plus or minus the square root of 4 plus 8 over 4. Or negative 2 plus or minus the square root of 12 over 4. Now back in algebra we learned to simplify that. We simplified our radical here, and we dealt with it in that way. We don't really need to do that here because we're going to have to use our calculator anyhow. We're going to be looking for an angle. So we're looking for the inverse cosine of negative 2 plus the square root of 12 over 4. And to see what that equals, and then the inverse cosine of negative 2 minus the square root of 12 over 4. We're trying to find out what angle has a cosine of that. So if we get our calculator out, we want second cosine. Okay, now we need to put parentheses for our numerator. Let me clear up the screen here, be a little bit easier to see. Second cosine. Now we need parentheses for our numerator. So we have -2 plus the square root of 12. Okay, it opened up a parenthesis for the square root, so we need to close it. Then we need to close it for the numerator, divided by 4, then close it for the function equals. And it gives us 68.5 degrees. Now, that was because this answer was positive, and so that's our reference angle, 68.5. So it's positive in the first. Cosine is also positive in the fourth. So our answer here is that theta could be 68.5 if our answer's in the first quadrant. If it's in the fourth quadrant, it's going to be 360 minus that. So we can put 360 minus second answer. And that would be 291.5 degrees. Okay, that gets it when we use the plus. Then we want to go back and we want to do the minus. So we can do second cosine, then parentheses, -2 minus the square root of 12. Okay, close the radical, close the numerator, divided by 4, close the function, enter. And it gave us an error. Well, when you stop to think about this, the square root of 12 is somewhere between 3 and 4 because it's somewhere between the square root of 9 and the square root of 16. So if you have a -2 minus 3, that's -5, which meant your numerator was bigger than your denominator, and that's never going to happen for the cosine. So we only ended up with those two. But we can use the quadratic formula for these the same as we did on the others. But it didn't change the page. I was hoping it would go back to where I had. Oh, okay. Well, I just discovered that I had taught several things and I had not turned the recorder back on, and I don't remember exactly where I was when I turned it off. So I'm going to start with this problem. If I've already done this problem, then you can just fast forward to a new section and hear that. If you need to hear this problem again, then you can listen again. But we've got the cosine of twice a minus 50 degrees equals square root of 3 over 2. And we solve this the same way we would solve the cosine of an angle equals square root of 3 over 2. We're just getting all of our possibilities. So what we're looking for is what angle has a cosine of square root of 3 over 2. And we know that that's 30 degrees if it's in the first quadrant and 330 degrees if that is in the fourth quadrant, because our cosine is positive. So what we do is we set 2a minus 50 equal to 30 degrees, and we're going to give all of the values. So that would be plus our 360k, or 2a minus 50 equals 330 degrees plus 360k, so that we get all of our values, not just between 0 and 360. So we would add 50, and then divide by 2. Now when we divide by 2, we distribute that, so it's going to be 40 plus 180k. Here we would add 50, so 2a equals 380 plus 360k, and then dividing by 2, we get that a is equal to 190 plus 180k. And so that gets all of our values, so that when we substitute them in, the cosine of that angle would be square root of 3 over 2. It's an example. If k is 0, then we would be substituting in 40. 2 times 40 is 80, minus 50 would be 30. Cosine of 30, square root of 3 over 2. If k is 1, well, then we have 40 plus 180, so that would be 220, times 2 would be 440, minus 50 would be 390. Well, that would be 1 rotation plus 30 more. So this is getting all of your angles whose reference angle is 30. And then this would be getting all of your angles in the fourth quadrant. That would give you that value. Okay, let's look at another one like that. Say that we have the sine of 5a plus 15 equals negative 1 over the square root of 2. So we're looking for all the angle whose sine is square root of 2 over 2. Now, since it's negative, we know that we're going to be in the third or the fourth quadrant. And if we rationalize that, that would be square root of 2 over 2. So we know our reference angle is 45 degrees. So our reference angle would be 180 plus 45, which is 225. So 5a plus 15 equals 225. Or in the fourth quadrant would be 315. 360 minus 45 would be 315 plus 360k. We want to get all of our values. So solving, we would subtract 15 degrees. So 210 plus 360k, and then divide everything by 5. So a would be 210 divided by 5 would be 42 degrees plus 360 divided by 5, 72k. Here we would subtract 15, so we have 300 plus 360k. So dividing by 5, we get 60 plus 72k. And then all you have to do to generate your angles is start with 0, so that would be 42. If k is 1, then it's 42 plus 72, or 104, or 114. If k is 2, then it's 42 plus 2 times 72, and you can start generating the angles that, the values that a could be. And we want to look at how we would go about solving this using our calculator. And this is a good way of checking things. Let's go back to a problem that we had at the beginning and see how we would use our calculator on this. And we've got the square root of 3 plus 5t equals 3 sine t. We want to solve this. We've already solved it in radians, which 4 pi over 3, that pi over 3 is 60, so that was 180 plus 60, which is 240. And 360 minus 60 was 300. So we know what these are in degrees. We're going to use our calculator and solve using degrees. Okay, so first of all, I want to make sure that my calculator's in the degree mode. And then on my window, I'm going to set it from negative 360 to positive 360. Since I'm in degrees, if I were in radians, I'd do negative 2 pi to positive 2 pi. And I'm going to do it by 90 degrees where my quadrants are. Now my y's, normally with sine, we're from negative 1 to positive 1, but we're going to have some other values, so I just made it negative 10 to positive 10. Now what we're going to do is we'll go to y equals, and for y sub 1, we're going to put in the left-hand side, the square root of 3 plus 5 sine x. For y sub 2, we're going to put in the right-hand side, 3 sine x. Then we will graph this. So there's the left-hand side. And here's the right-hand side. Now what we want to know is where those intersect. Where they intersect gives us our solution. So we can do second, calculate, intersect. And we can move our cursor to here, and that's the first curve, so we'll press enter. Second curve, enter. The guess, we can enter. Now it gives us negative 60 degrees, which we know is 300 degrees. We want to go back and give it as a positive angle, so 360 plus negative 60 would be 300. Then we can do the same thing, second calculate, number 5, and we'll move our cursor to the other place where they intersect. And we'll do enter, enter, enter. And that gives us our 240 degrees. So we can you can check your solutions using your calculator, but you want to work through with the algebra. Let's look at how we would check one where we had to factor some things. Let's look at this one. And we could go through our calculator. Now again, we did this one in radians, but this would be 0, this would be 180, reference angle 60, so that would be 240, and that would be 300. So we can take our calculator. Now we're going to do from negative 360 to positive 360, and in fact we could actually do from 0 to 360. So for our first one, let's just clear both of those out. Now this equaled 0. So we could put in sine x plus 2 sine x cosine x. And we can graph this. Now, because that's a little hard to read there, let's change our window. Let's make it maybe negative 3 to positive 3, just making it a little bit bigger. Now we're really only wanting from 0 to 360, so we don't really care about these back here. But what we're wanting now are the zeros. And so we can do second calculate because we were wanting to know where that equaled 0. So 2. And we know that right there is the 0. We can see that. So let's go ahead and get our next value. So we would about where it is. Now remember, we want the left bound, so we want it uh, to the left of where we cross. We want the right bound, so we move it to where it's to the right of where we cross. And then we press enter. And that gives us the 120 degrees, which this was 60. And reference angle 60, so that was 120 degrees. I think I had it in the fourth quadrant a while ago, which I shouldn't have. Then we would do second calculate the 0. We'll move the cursor. It's to the left of where we are. We want to be to the right. And then press enter. That gives us the 180, which is pi. Second calculate 0. We want to be to the left, then to the right, enter, and that gives us the 240, which is the 4 pi over 3, is the 240. That's the 180 plus 60 would be the 240. And so that gets us our values. And so you can use your calculator on that to come up with those values. Now let's look at one that was, we could do the same thing on the one that was the quadratic formula. It equaled 0, so we could graph that. And even one, let's try one of these, where we have, okay, let's clear. And let's just see if we can do this. We'd have the cosine of 2x minus 50, close parenthesis, whoops, that's not where we want this. We want it in the y equals. The cosine of 2x minus 50, close parentheses. And then for the other one, we want the square root of 3 divided by 2. Now we may have to go back. Let's graph it. We may have to go back and make it from negative 10. And in fact, we don't need all the negative sides. Okay, that looks like it gives it all, but we don't actually need those. We just need from 0 to 360 because we're just wanting those answers. And so we could go through then and we could find the points where these intersect. And it's a little bit hard to tell where they're intersecting there if it's in more than one place. We could tell if we didn't maybe if we go from 0 to 3, that will blow it up just a little bigger. Okay, so you can see we're intersecting here, 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 and here. So we can do second, calculate, and we're wanting the intersect, which is number 5. And we could check any one of those. Well, let's go back to the first one. So we would press enter, 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 and that gives us 10, which is not what we got. Okay, let's look at this. We've got x equals 10, and we got 40, but we didn't go through and figure up what our values would be. Let's go through and just look at this. If k is 0, then we're going to have 40 plus 0, which is 40. Okay, if k is 1, we're going to have 40 plus 180, which is 220. And if k is 2, we would have, a value we could go on up. That would be 360 plus 40 would be 400, and we could go on from there. $360, which equals 400, and we could keep going. Over here, if k is 0, then we have 190. If k is 1, we have 190 plus 180, which is 370, which is a coterminal angle of 10. This 400 is a coterminal angle of 40. And so we would be starting over. The next one we get would be coterminal with 220. But that is why when we did this, we got 10. So there's one of our answers. If we wanted to come up second, calculate number 5, excuse me. We want to do the intersection. We would move to our next point of intersection. We can press enter, 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 and that gives us the 40. Second, calculate, intersect. We can move to our next point of intersection. Do enter, 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 and we get our 190. Enter, 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 and we get the 220. And so that gets all 4 of our solutions between 0 and 360. So you can use your calculator to check your answers. But we go about solving our trigonometric equations the same as we do our algebraic equations, and then we give our answers.